Hello, my name is Martin Smith, and for those of you who watched my first video on Photon Drag, I erased it, and you have my apologies for even putting it on YouTube network. It was pretty bad. Most YouTubers think poorly of anyone who erases stuff and rewrites very bad mistakes, but for all of you who saw my first video, you have my deepest apologies. I got a lot of facts that were incorrect, and I'm going to try and go back over this a little bit more. Normally I talk about wags and swags, wags being wild-ass guesses and swags being scientific wild-ass guesses. This one is one above that, and I'm going to call it a what? That is a wild-ass alternative theory. This is not my theory. It was one bantered about when I was at Appalachian State, Boone, North Carolina, in 1984. And it was talked about so much that I always considered that it was fact. And the photon drag theory that I'm talking about says that as a photon goes by small charged particles in space, those particles are dragged closer to the photon as the photon is approaching, and because it's closer, it has more of a drag as it's going away from the photon. So I will be going over that. And if you talk about alternative theories, and this theory goes against the universe expansion theory, then people are going to turn around at you and go, what? And yeah, this is a wild-ass alternative theory. Another aspect that needs to be talked about on this before I get into it is space flatness, or universe flatness. We generally think of our solar system as being flat, as in everything revolves around one axis. And though Pluto has a different rides on a different plane than the asteroid belt that it's supposedly within, in my opinion that means it's not in the same orbit. However, there is something known as the Oort cloud, and it's a theoretical cloud, and that means where all the solar winds either slow down or stop, as in they only have so much momentum and they're going straight out from the sun, and they don't have a whole lot of rotational energy. So there's a point in time where they either slow down or come back to the Earth, and or back to the sun as comets. Now we see a lot of comets with trajectories that can't be really worked out properly. So the assumption is that there's an Oort cloud, which would mean that our solar system is actually spherical rather than flat. We look out and see galaxies, and most of those are flat, but not all of them. The ones that aren't flat we generally refer to as clouds, or flatness of the universe is where I got stuck. And we talk about the visible universe and what we can see being 13.8 light years in distance. Well, the farthest we've ever seen is quite a bit less than that with telescopes. So I'm not sure where the 13.8 comes from. But that is a visible universe, and it is a spherical universe. So where they're coming up with flatness is in fourth-dimensional space-time. And if the fourth dimension in space-time goes flat, then the universe is stationary. I mean, it's non-expanding. If it's curved space, then they're talking about the universe expanding. When they're talking about the universe being flat, it's good flashy headlines. It's very confusing. It made me think, like, what in the world are they talking about? And I had to sit back and mull this over in my mind for a while before I could keep going on this particular video. But they are talking about a fourth dimension, not the three dimensions of space, is spherical. So the universe itself is spherical. The visible universe. What it is past the visible point, nobody knows. I mean, we can make some guesses on it. But anyhow, moving on. Do remember that the expansion of the universe has been theorized because of the redshift. Now, physicists pretty much never get mathematics wrong. The problem is that when mathematics comes to 3 or 4 conclusions, they almost always get the conclusion wrong. They pick the wrong conclusion and go with it. This one, like I say, was one of many possible conclusions for the redshift, and this all revolves around redshift. So the other thing that photon drag does is if the particles are denser in one area than another, such as the sun putting out huge volumes of positive and negative charged particles known as the solar winds, they will be more dense towards the sun, and they will become less dense with a factor of 1 over r squared. As they get farther away from the sun, the density gets smaller and smaller. This lenses, and here we're talking about an electromagnetic lensing rather than gravitational lensing. I will not be going over that one in this video. This video is about photon drag only for redshift. Okay, starting off with some relative terms where we're starting from. When we talk about photon drag, we're taking gamma rays and bringing them down to X-rays, taking X-rays, bringing them down to visible light to radio. And if I'm looking for this to extend into my search for gravitation, in this particular search that I'm making, then I'm looking at taking radio waves and taking them down to gravitons. So the idea is to have a very large pool of gravitons. So we're starting out with the biggest gamma ray mix off of Wikipedia, and we're looking at teravolts, and we looking at it in EV range rather than range of joules. Hypernova is some of the biggest we've seen. If I read it properly, we're looking at 3,000 max on the tera electron volts. That's very high energy photons. So whether there's a maximum energy photon or not, we don't know. Okay, going to here, furthest supernova spotted from Earth is SN UDS10 WIL, and that was spotted about 10 billion light years away. The estimated distance, visible distance, is 13.8, but what's happening is our telescopes are in the visible range, and they're not necessarily in radio. So the radio range would be the farthest we would be able to see just because of the redshift. Now, this is a theory about what redshift is, where redshift is coming from. It's not necessarily a given. We don't know for sure. So going with Hubble constants, the slowdowns, we have this. So the redshift is calculatable with the Hubble constant and with the current one. And you'll notice that these two, the plus or minuses, don't match. So there are some discrepancies in this, in the math. We'll get better as we get better telescopes. An old theory, photon drag, it was thrown out. My joke of the day was called a what? It's a wild-ass alternative theory. This photon drag is an alternate theory. It's an alternate theory to the expansion of the universe. The theory of the expansion of the universe came from the redshift, as in redshift over distance. So first we need to go over what a photon is. My best guess, I'm going again with an old theory, the double helix theory, where we have a positive and a negative, and they're spinning around in a helix, one wavelength. But this does not describe the diameter, the distance between the positive and negative, and that's something that needs to be dealt with. distance between positive and negative charges, I have a WAG, wild ass guess, at 5 times 10 to the minus 10 times the wavelength. And I got that off, you can see the video on photon amplitude that I did, and that will describe that. If you also want to see photons as particles, you can. You can see them as particles, you can see them as masses, you can see them as energy waves, you can see it as energy propagating through luminiferous ether. Those are 3 ways to visualize a photon, and quite honestly, I think all 3 rays are correct. I think they're interchangeable. I will be dealing with positive and negative charges only in this particular video. So if you want to see them, I think this is the proper way of getting there. Go ahead and pause it and write all this down. I changed mass E equals mc squared and then just converted, and also that this formula for black holes, the 1/2 came from the fact that there are 2 charges, a positive and negative charge. So instead of being a set number here, they cancel out. So there are 2 different numbers in here. The 1/2 comes from the fact that there are 2 charges, so each charge gets 1/2 the energy. And then converting from radius to diameter, you double it again, so you knock off the 1/2. It's confusing, but that's the way I got there. The theory of drag, this is the paperwork I did on the last video, and it was lacking, so I added those other pages to it. Going over this, it's saying we have a positive and negative charge. We have, if you go out into space and you get real small, where you have, even if we're talking about an atom, where you have a positive charge inside of a negative charge, there's distances between those charges, and those charges are going to have effects on each other. So as they're coming together, this theory of photon drag, it's saying that we're using electromagnetic waves, and we're assuming that those waves extend past the actual center mass or center of the photon charge. So if the waves are way out here, then as it approaches another electron wave, before the actual photon gets to it, it's going to have effects on it. So it's a positive, negative, will draw them closer together, and as it is, it's going to move this closer here. So when the positive aspect of the photon goes by an electron, the electron actually moves a little bit, so the distance between here is different. As photons turn by wavelength, they do 1 revolution per wavelength, and it's saying that you never really know which direction the photon is going to interact with a positive or negative charge. You never know what type of charge you're going to get, and it's all random through space. You figure they're going through 1 charge about every centimeter. You're looking at thousands of light years in distance. I mean, even if you're talking about 100 light years in distance, that is a lot of centimeters that this thing's going through. It's traveling past enormous numbers of charges. So just by statistical referencing, you can say that it's going to slow it down if this theory is correct. And if you're reading this as I am scrolling upwards, scrolling the page up, and let's see here, go back to here. This is an important part, dynamic friction. This is where I think photon drag failed, because we know dynamic friction works for atoms or for particles, because as a particle moves through space, it gets closer to another, and the gravitation either pulls the particle to the object, or big object to the particle, or a little bit of both. And they're closer together when the particle keeps going. So what happens is the gravity is stronger as the particle is moving faster away from, and the particle's actually losing energy or losing velocity as the mass that it's passing by gains a little bit of energy. So dynamic friction is not what we're talking about. We're not talking about a gravitational reaction. We're talking about an electromagnetic interaction. Going to the second page of my old video, I'm looking at it like this. So we have high energy. You got to remember that high energy photons have a smaller wavelength, and the amplitude theory and amplitude numbers that I came up with state that it's directly proportional. The distance between the two charges of a photon are directly proportional to the wavelength. So as the wavelength gets smaller, the diameter of the photon will get smaller, or even the diameter of the effects will get smaller. So as we go through here, we have a process of the photon going by, charged particles, and this is the reaction. We have low energy photons going by. They'll have less effect, but they are directly proportional, so that if you look at the visibility spectrum of hydrogen atom per se, these things don't get farther apart or closer together. They redshift all in one direction. A side note that I'm going to definitely stick with, because I actually found this YouTube facts right here. I did find something that correlated with this, saying the amount of charged particle photons pass in, say, 1,000 light years should equal a very long fiber optic cable. We should see redshift in optical cable, and we actually do see redshift in a fiber optical cable, and that is, again, a YouTube fact. And it was something that I was guessing on when I first did this. So we've gone from a wild-ass guess to a YouTube fact on that one. Okay, going back to the basic model, these are triangles. So we have a triangle here to here, and a triangle from here. The distance is greater, so therefore the pull on this would be less, going this direction, from here to here. And the distance from here to here is smaller. Because the distance is smaller, the magnetic forces will be greater. So the slowdown would be greater than the acceleration. So electron magnetic pull of 1 minus pull, or actually, let's go with the math. The pull of number 2 minus pull of number 1. Pull of number 2 is greater, so the energy lost in joules would equal a redshift. And that is the basis of the photon drag right here. It's the fact that these are closer together when it's going away from, and that means the pull is greater. If you were to flip them around, the opposite would be true, but again, it would be pushing away from, so you would have a greater slowdown getting closer to it than you would an acceleration, and again, you would have a redshift. That is the concept of photon drag, and I will probably get into electromagnetic lensing after this one. We'll see. I might go back to farming videos. This one was a bit of brain fry getting this done, so I'll see you on the next video.